Hello. In this video, we're going to answer the question, what are vectors? Well, vectors are quantities that involve both a magnitude and a direction. So here's an example of a vector. Whenever I say a magnitude, I'm talking about its length, and then obviously you can see that this has a direction. Now, one thing that makes vectors special is that you can move them anywhere in the plane, and it's still the same vector as long as you don't change its length or its direction. And the standard position of a vector is starting right here at the origin. All right, so now let's jump into how can we use vectors. Well, to use vectors, it's important to be able to write the component form of a vector. Vectors have two components, a horizontal and a vertical component. And here's how we find those components. You just make a right triangle, and however far it goes in the x direction, that's its horizontal component, and this would be the vertical. So we can see that this goes from 2 to 7, so it has a horizontal component of 5, and then the vertical goes from 2 to 8, so the vertical component is 6. And now thinking back to what we were talking about earlier, if we move this to the standard position of a vector, look where it ends, right at 5, 6. And so let's write the component form of this vector v. It has an initial point at negative 311 and a terminal point at 940. All you have to ask yourself is, how much did the x change and how much did y change? Well, the x went from negative 3 to 9, so that's a change of 12. And the y went from 11 to 40, which is a change of 29. So this vector with this initial point and this terminal point, so where it starts and where it ends, has components 12 and 29. All right, vector addition and scalar multiplication. This looks a little bit more confusing than it actually is, so take a second to write it down and then I'll explain it all. So basically all it's saying is add the corresponding parts. If you have u plus v, add the x components and add the y components. That's u plus v. If it's scalar multiplication, so if you have just a number multiplying a vector, just multiply that number on the x and y. All right, so let's try that out. We have a new vector u plus v made up of u and v. So we'll just add together the corresponding x's and the y components. And we get that u plus v has components 1 in the horizontal and 3 in the vertical. All right, in the next round we have 2u minus 3v, so I first start by just multiplying these by 2 and these by 3. It gives me 10, 6 minus 12, 0. So 10 minus negative 12 is 22, and 6 minus 0 is 6. All right, but how would we represent this graphically? To combine vectors graphically, you must put them tip to tail. So let's look at what u plus v would look like. So right now, both of these are in standard position. But if I move u to be on the tip of v, notice that u has components 2, 3. So I'm just going to have those same components. This is u. Or I could move v. v has components negative 2, 5. So I'm going to draw v over here. As you can see, they both end in the same spot. So I could just choose one of those to do. The new vector, u plus v, is the combination of these. And that vector has components 0, 8. And we can verify that algebraically. Going back to the beginning, we see that u has these components, v has these components, and adding them together just gives me right back that 0, 8 again. Negative vectors switch both of the components of that vector. So this is vector v right here. This has components 3, 5. So the negative of v has components negative 3, negative 5. All right, so we're going to represent graphically v minus 2u given these two vectors. So v is just 0, 4, and there's nothing that we're doing to it, so I'm going to start with v. Now for tip to tail, I'm going to put negative 2u at the end of v. So first I need to find negative 2u. Negative 2u would be negative 2, negative 4. So from v, I'm going to go back 2 and down 4. That's minus 2u. So my final vector is just the initial to the final terminal. That has components negative 2, 0. All right, writing vectors as linear combinations of I and j. We're going to write them as a vector sum, which is just its horizontal component times I plus the vertical component times j. And that's just because any vector can be expressed as a linear combination of these standard unit vectors I and j. So AB just becomes AI plus BJ. So 3, 2 would just become 3I plus 2j. As simple as that. Okay, now we have the dot product. For A with these components and B with these components, you just multiply the corresponding components and then add them together. And then if that equals 0, then we know that the vectors are orthogonal, which just means perpendicular. So let's find A dotted with B for each of these cases. So I just multiply the corresponding parts, 5 times -3 plus 1 times 15. That gives me -15 plus 15. So this is 0, which lets me know, yes, these are orthogonal vectors. So you give it a try over here. We should have gotten 2, letting us know it's not orthogonal. All right, that's my Basics of Vectors video. Goodbye.